Hi everyone, Jason here from Fireball Tool, and we're here to do another build today. And as you can see, it's a Sawhorse. Highly sought after on the job site. I actually have the other match to this one, and every time I go to use it, somebody's already using them. And this Sawhorse actually came out of some necessity. Doing some remodeling in the house, and we needed to be going up elevators and going down hallways, and you guys know fixed Sawhorses always pose a big problem with that. I came up with this, and so there was a few requirements. For one, it had to be very lightweight because I want to be able to carry two Sawhorses at the same time. Second, it needs to be very strong. I want to be able to hold up to 500 pounds or more each, so 1,000 pound capacity. I want it to be of a hybrid construction, wood on the top, steel on the bottom. I like a taller Sawhorse. It seems like every Sawhorse that's out there is just too stinking short. So this one's measuring at about 37 inches. I like a Sawhorse anywhere between 36 to 38 inches tall. If I want to work off the back of my tailgate of my pickup truck, this is closer to the height of a tailgate instead of those short ones where your material is might be going at an angle. So having a taller Sawhorse is mandatory. So this is version 1.0, and I'll walk you through some of the details here. The first thing, as you can see, is it folds up. Okay, it does this by a piece of 1-inch hot rolled electric weld tubing inside a piece of 1.25 inch DOM tube, and DOM stands for drawn over mandrel. The DOM tube doesn't have a weld inside of it, so basically using this like a bushing or a pivot joint. Here's our little tabs that the 2x4 screwed into, so when this thing gets wore out we can replace it. And this is another part of the magic. This is what holds the spread at a certain distance. At the time I was building these, I didn't have what I really wanted to use, so I just kind of came up with something, and I had this 1/8 inch cable, and I had some of those punch dropped outs from the shear, and I just drilled a hole through there and welded up the end so the cable was permanently fastened. I know this is hard to replicate, so in the version we're going to build this afternoon, we're going to change this. So look for an update on this. I want to be able to put more stuff in the back of my truck, service truck, or hang on the wall when I'm done with it. This should take up very little room in your shop. When we're done building, we're going to be building 3 sets, so 6 more Sawhorses total. Let's get building these things, right? This is one of my favorite tools in the shop, the Amoeba German automatic bandsaw. Slicing up some tabs to hold the 2x4 to the spine of the Sawhorse. Not worried about deburring anything at the moment. We're using this aluminum rod just to take up all the slack in between all the pieces so that we can clamp everything nice and tight. Just eyeball the holes, no need to lay out. This isn't a very critical dimension here. cutting the bushings that the legs of the sawhorse get welded to. The Meba is a pretty accurate machine. It's holding a tolerance of plus or minus 5/1000ths of an inch on these tubes, so overall I'm pretty impressed with it. Some of you guys might recognize this beast. This is my 1943 Kerning Trekker horizontal milling machine. We're going to use this beast to coat the DOM tubing to this square tube. I love taking these opportunities to share the machine with you because some of you guys are just starting out in the metalworking, but it's just fun to see an old piece of equipment just do some serious work. So let me show you kind of what I want to do with this thing. Okay, so what we're going to do is I'm going to put this end mill up into the machine and we're going to run the piece of tubing right into the side of it and we're going to cope it. Okay, this is a R8 collet that goes into a knee type milling machine, and about the largest size that you want to go in here is probably about a 7/8. Okay, that's where this is its limitation on a normal little knee mill, where this beast can handle stuff like this. Look at that. This is a 2-inch end mill. Someday maybe we'll do some work with this thing, but running 10 horsepower, we got some serious metal moving power. So let's throw the little end mill in here and let's hog some material. I know you just saw me cope those tubes, this tube steel on the Kerning Trekker mill, and you're probably thinking to yourself, I don't have a 10 horsepower Kerning Trekker mill to cope these, so what am I to do? Here's another option, and we're going to do this all on the vise and make a nice tidy little seam here. And you can see, I think anybody should be able to weld that, and it actually looks pretty nice. So I'll show you how to do it. First, we're going to start with some pieces of angle iron. These are going to be like vise jaws, and I just welded a piece of 1/2 inch hot rolled round, and that measures 1.5 inches by 1/2, and I put a little radius on here so that when we go to clamp this in the vise, it leaves this nice smooth transition in here. Basically what we just do is we set these little vise jaws up in this vise here. We center them up to each other, and you're going to probably want to practice with this a couple times, so cut yourself some samples. And what I like to do is get a little squeeze on it, just enough to where it stays there, and then eyeball it looking over the top and just center it all up in there. And you can see I'm close to the full depth, and then what we just do is we just give it a squeeze. See how fast this is, and you can play around with how much squeeze you need, but I probably squished it in about 1/2 inch or so. And all we do is we back it out and we're left with this. You can see the nice little grind marks in there and what the end profile looks like. Okay, but we're not done yet, so it should look something like that. Pull the vise jaws out, and we flip it the other way. So here's where we just squished. We turn it 90 degrees in the vise, and we grab about 1/4 inch of the jaw on there, something like that. Okay, just barely grab the end, and what's going to happen is as we squeeze this, it's just going to continue that fold in. And use your discretion on how much you want to squeeze. This just comes with practice. And when we're done, we're left with something like that. And if you feel that it's not enough, we can put it back in the vise and squeeze it again. Okay, now let's go a little bit more. That was about a little half a turn more. And as you can tell, that's what we're left with. Okay, so you can cut all your tubes to the exact length you need, put a little squeeze on them. You saw that took just literally seconds to do. You get better at it as you go through there, and then you'll weld all the way around. I left this one open just to show you how the fit looks, and that's what you do if you don't have a Kerning Trekker 10 horsepower milling machine. All right. All the material is cut, holes are drilled, ready to walk you through the assembly. Everything is referenced off this square tube I have clamped to the back edge of this table. We have spacing between the legs so that if you don't do it this way and the legs get a little twisted, this assembly will still close. Don't forget to orientate your feet correctly, the angle. So you can see one's going one way, one's going the other way. And as you can see, I have everything on spacers. This is a 1/4 inch, and underneath these are 1/8 inch spacers. The round tube has an 1/8 inch wall, so we need to put an 1/8 inch spacer underneath all the legs to align the center line. Clamp the mega square with this bar across there, because if you were to clamp on this diaphragm, you might end up distorting the sides. So use a spreader bar there. We're just going to be welding across here and here and around the sides. This extension here is so you can either put a bolt, but I'm just going to tack weld this shut so this assembly won't fall off. This goes up. And also remember that the holes get positioned this way instead of up and down. This is a 1x1 square tube, and this is 3/4 by 3/4 square tube. And this is designed on purpose so that you have this weld gap in here, so you can put a little fillet weld in there. If this was flush and you welded there, you got to grind it back off so that you don't have so much grinding to do, or none at all, in my opinion. Okay. So that lines up like that, and as you can see, that little clearance in there allows you to weld, and you weld right here. about ready to put the chain on here, and I've switched from a cable to a chain for a couple different reasons. You can find this at Home Depot or any of your hardware stores. This is basically just a swing set chain, and this actually has a load lifting rating of I think about 250 pounds. And what I don't want you guys to use is use this stuff, jack chain. As you can see, not for overhead lifting, 29 pounds working. This is electrical stuff for it's actually open-ended to where that could potentially fail. I cut my lengths pieces here on the little shear, and it measures roughly 22 inches from the end of eye to the end of eye. And I'm using this 1/4-20 hardware that measures 1 1/4 inches. Put a washer on the end of it here, thread it through the eye, and we'll bolt it in. And we don't need another washer on that side, we'll just use a lock nut. And the lock nut's important because we want it to be snug, but we're gonna tighten the lock nut, but we're not gonna cinch it down. We want a little bit of slop in here. And we just stretch over to this other side here, make sure our chain's not twisted. Okay, really easy. Just get it to where the threads are locked on the nut. Now, you remember when I told you about those holes being offset when I showed you before? Here's why. Look at that. So now the chain can swing past itself and the framework can close. The length of the chain's perfect, it's not dragging on the floor. You could probably even hang it off some hooks or something off this too.
Doing a load test with 2,000 pounds on these things. These sawhorses will never see this kind of load, but it's always fun to test its max capacity. Overall, these sawhorses are a very fun project to build. If anybody wants to build them, I have the plans uploaded on the website at fireballtool.com. Please subscribe for more awesome content, and I'll catch you on the next one.